Good morning. Today we are going to study trigonometric functions. Now, in our earlier classes, we have studied trigonometric ratios of acute angles as the ratio of sides of a right angle triangle. We will now extend the definition of trigonometric ratios to any angle in terms of radian measure and study them as trigonometric functions. Now what we do is consider a unit circle. Now what do you mean by a unit circle? Circle having radius equal to 1 unit. Okay. So in this, we have considered a unit circle and take it in such a manner that the center coincides with the origin of the xy plane, and the xy plane is something like this. Consider a point P x comma y on the unit circle. Okay, let it make an angle theta with the positive direction of x axis, or okay, so what we do is, if you drop a perpendicular from OP onto the x axis, okay, so this point, let's call this n. Now this distance ON is x and this distance PN is y. Now from this right angle triangle ONP, so in triangle ONP, okay, so what do we have? You can use Pythagoras Theorem and see that x square plus y square equal to 1, as triangle ONP is a right angled triangle. Okay, so we get, if you substitute, so this is one thing. Okay, now one more thing. This is unit, means OP, the radius of this circle is 1. Right. Now, so in this triangle, what we can do is, we can write y over 1 is sine theta, or you can write sine theta equal to y over 1 and cos theta equal to x over 1, which gives us x equal to cos theta and y equal to sine theta. So what does this mean? But what are x and y? X and y are the coordinates of the point, any point P lying on this unit circle. So it means that the x and y coordinates of any point lying on this unit circle give us the corresponding values of cos theta and sine theta, where theta is the angle which OP, that is the line joining the point to the origin, makes with the positive direction of x axis. Okay, so this way it helps us that if you are taking any unit circle, any point on that unit circle will satisfy this condition. And what is that condition? That the x coordinate of a point lying on the unit circle will give us the corresponding cos theta, and the y coordinate will give us the value of sine theta. Okay, now, so from this we arrive at 2-3 conclusions. First conclusion, over here we have seen that in the right angle triangle, x squared plus y squared equal to 1. So substituting this value of x and y in this equation, we get, but x squared plus y squared equal to 1, it implies that cos square theta plus sine square theta equal to 1, which we already have done in the previous classes. So here we can generalize it, where theta could be any angle. Theta could be any angle. Now it's not only restricted to the acute angles, even if theta is here, the point is here, so theta would be an obtuse angle, or the point is here where the theta would be an angle more than 180, or the point P is here, so the theta is more than 270 and less than 360. So, no matter where the point lies, the x coordinate always gives us the value of cos theta, the y coordinate always gives us the value of sin theta, and with this we have also seen that no matter what value theta takes, this result is satisfied. Now, this is the first thing. Now, let's call it 1. Now, dividing 1 by cos square theta. So, what do we get? 1 plus tan square theta equal to sec square theta. This is the next result. Okay. Same way, dividing, and how did we get this? Sin square theta over cos square theta is tan square theta. 1 over cos square theta is sec square theta. Now, similarly, dividing 1 by sin square theta, we get, now this becomes cos square theta over sin square theta, which is cot square theta, plus this is 1 equal to 1 over sin square theta is cosec square theta. So, this result is also satisfied and is not restricted only to acute angles. Now, let's proceed further. Again, I am repeating what we have done just now, that we have taken a unit circle and we have seen that any point on the unit circle is such that its x coordinate gives the value of cos theta and its y coordinate gives the value of sin theta, where theta is the angle which the line joining that point, that is OP, makes with the positive direction of x axis. Now, let's consider a point lying. Now, again, what we do is, let's again consider this. So, when, let's call it x, this is y, this is a unit circle, O, this is P x comma y. Okay, this is a unit circle. It means if it's a unit circle, all these points would be at a unit distance from the origin. So, the coordinates of this point, okay, the coordinate of this point would be what? It lies on the x axis, and so the x coordinate is 1, y coordinate is 0. The coordinates of this points are 0, 1. The coordinates of this point are -1, 0. The coordinates of this point are 0, -1. Also, at this point, let's call it A, let's call this point B, let's call this point C, and let's call this point D. So, we have seen the coordinates of point A are 1, 0, coordinates of point B are 0, 1, coordinates of point C are -1, 0, and coordinates of point D are 0, -1. Again, at this point A, the angle is made by this point with the x axis is 0. So, theta equal to 0. Here, point B, so line OB makes an angle 90 degree. Okay. So, here theta equal to 90 degree means pi by 2. Here we are dealing with angles in radians. So, we could even write it as 90 degree, but we prefer writing pi by 2. Now, here at the point C, this is 180 degree. 180 degree means pi when theta equal to pi, and at this point it is 270 degree. 270 degree means theta equal to 3 pi by 2, and when you are back to A, you get theta equal to 2 pi. So, we have seen that at OA at OA theta equal to 0 and coordinates are 1, 0. It implies that when theta equal to 0, x equal to cos 0 equal to 1. Y coordinate equal to sine 0, which is y coordinate is 0, and hence we get the value of cos 0 as 1, sine 0 as 0. When theta equal to pi by 2, pi by 2 means 90. Coordinates are 0, 1. So we get x equal to cos 90 equal to the x coordinate, that is 0, y equal to sin 90 equal to 1, and hence we get these values. Now this is at A, this is at B, this is at C. So now when theta equal to pi, coordinates are -1, 0, and this gives us x equal to cos of pi, which is -1, and y is equal to sine of pi, which is 0. Now when theta equal to 3 pi by 2, which is 270 degrees, coordinates are 0, -1, and so x equal to cos of 3 pi by 2 equal to 0, and y equal to sine of 3 pi by 2, which is equal to -1. So you have seen that we don't have to mug up all these results. We simply keep it in mind that we consider a unit circle. Any point, the coordinates of any point lying on the unit circle will give us the corresponding values of cos theta and sin theta, and accordingly you know the values of cos and sin for all the points, means points when theta is 0, when theta is pi by 2, when theta is pi, when theta is 3 pi by 2. And as you can clearly see, when theta is 2 pi, the point we are back at the point A, and so when theta is 2 pi, then also we come to the same point 1, 0, and so cos 2 pi is 1 and sin 2 pi is 0. Thank you.